Hello everyone, welcome to my lecture. Here in this lecture I have selected a question from the chapter relation and I will try to explain here. So what is the question here? If R is equal to if R is a set, initially R is a set, how you come to know that R is a set? R is a set means all the properties of set is written here. This is written in set builder form. Okay, it is a collection of all those ordered pairs x, y. Initially, the set R contains the elements of the set R are in form of ordered pair x, y. So what type of x and y will be there? X and y should be whole number always. Natural numbers including 0 are known as whole numbers. Natural numbers and 0 is known as whole number. That means R will contains all those ordered pairs where in place of x as well as in place of y only whole numbers will be there. If I say that 2 minus 5 belongs to R or not, if this symbol represents elements always, that means a symbol to pisot prakate hore element e bujhai. So this one is an element of R or not? This one is an element of this one relation or not? What do we say? To be an element of these are elements. To be an element of the relation R or the set R, what is the main condition to be satisfied? The main condition is that both x and y should be whole numbers. Here we have got that 2 is a whole number, no doubt, but minus 5 is not a whole number. So that's why this is not an element of the relation R or not an element of the set R. So we have to mention like that. This is not an element of the R. And what is the other condition? The other condition is that twice x plus y is equal to 8. That means the values of x and y after putting here, that expression should be exactly equal to 8. Suppose 1 and 3 belongs to R or not. It is an element of this one R or not. First condition, x, this is a place for x and this is a place for y. X and y both are whole numbers. It's okay. First condition is satisfied. What is the second condition? The relation between x and y is 2 into x plus y should be equal to 8. What is the value of x here? 1. What is the value of y here? 3. So what is the answer? 5. Is it equal to 8? No. So that's why as 1, 3 does not satisfy this condition. 1, 3 does not satisfy this condition. What is the condition to be satisfied? Twice of the x component plus y component is equal to 8. Hobo lagibo. কিন্তু আমি x and y value put করতে চাই, so we have got 5. That means this expression does not satisfy these conditions. This 1, 3 ordered pair does not satisfy the condition. That's why this is not an element of the set R. That means to be an element of the set R, both the conditions should satisfy. First of all, they should be whole numbers and they should satisfy this condition at the same moment. Then and then only all those ordered pairs should be there under set R. Now relation means what? Relation means what? It is always defined between two sets. Duta set also defined kora jay. The sets may be the same also. Remember that if R is a relation from A to B means R is a subset of A cross B. It is known to you A cross B contains only ordered pairs. Always A cross B contains ordered pairs. Operation between two sets itself is a set. Duta set of operation koile hi hore set e hoy. And R is a subset of this one means as A cross B contains only ordered pairs. Tar mane A cross B namar je set ase ei set er okol ki thakibo x, y. What is the main condition? X belongs to A and y belongs to B. That means A cross B contains only ordered pairs. What is the main condition to be satisfied? The first component always belongs to the first set and second component y belongs to the second set. As R is a subset of this one, R is nothing but a real number. It is real number no. R is a subset of A cross B. So R is a subset of A cross B means what? R is a subset of A cross B. That's why R also contains ordered pairs. It also contains ordered pairs. So R also contains ordered pairs. As R is a subset of this one, subset means what? Whatever maybe the elements will be here, all those elements will be here also. That as A cross B contains ordered pair, R also contains ordered pairs. So remember, relation means what? It is a set. Subset itself is a set. R is a subset of A cross B. First of all, relation is defined from A to B means what? Relation means it is a subset of their Cartesian product. Cartesian product contains ordered pairs. That's why relation always contains ordered pairs. So that's why it is a relation, because it contains ordered pairs. Zibilak set of ordered pair contain correct. These are always relations. What is the relation between X and Y? And in that relation, one specific criteria should be there. In specific relation between there, the first component as well as the second component. Okay, so we can easily draw an arrow diagram to visualize it. Suppose A is a set and B is a set. If R is a relation from A to B means what? The elements of the first set are always represented by X and Y always belongs to B. Okay, the relation is in between X and Y is that here it is given Y is equal to 8 minus twice X. That is, for each and every values of X, you will have a corresponding Y. This is a relation between X and Y. Are you getting my point? The elements of the first set are known as or represented by X, and elements of the second set are always represented by Y. Don't forget it. Suppose X is equal to 1. Then what is its corresponding value of Y? A 1 or corresponding value kiman hobo jenaki X or corresponding Y is there. Then what is the corresponding value of Y for X is equal to 1? X is equal to 1 or Y corresponding value to kiman? To know about it, you have to put the value of X equal to 1 here. So 1 put koile kiman hobo? So 8 minus 2 is equal to 6. That means Y is equal to 6. You are getting the corresponding value. That means 1 is related with 6. Related, I am mentioning the word once again. 1 is related with 6. Under this condition, From where you have got this condition? Yes, this is the condition. 2i6 plus Y is equal to 8 means what? Y is equal to 8 minus 2i6. That means Y is expressed in terms of Y or in terms of X. Y to come X of express first. Okay, so I think you have got it. Okay, so 1 is related with 6. Got it? So suppose for X is equal to 5, what is the value of Y? X is equal to 5 means 5 is a 10. So Y is equal to minus 2. That means 5 is related with minus 2. They are always represented by pairs. That means this one pair is 1, 6 and this one is pair is 5, minus 2. Listen. This is the component for X, this is the X component and this one is the Y component. That means under this one condition, obviously you have got it, Y is equal to 8 minus twice X. This ordered pair satisfies this condition. Condition means what? If X is equal to 1 and Y is equal to 2, both the left hand side is equal to right hand side. If for X is equal to 5, just put it here, you will get Y is equal to minus 2. Both the ordered pair satisfies this condition. Satisfy this condition means after putting the value of the variable X and Y in the respective places, left hand side to right hand side. Satisfy kora mane variable bilakor value left hand side or right hand side bohai dile duita side equal hoy jay. The first components which will satisfy these conditions are known as domain elements. They are known as domain elements. They are known as domain elements. And the second components are known as range elements. The whole set B is known as codomain. The whole set B is known as codomain. But from the set B, only the related elements, 1 over 6 related, 1 over belek kuno element related hoy thaka nai. 6 is related with 1, that means 6 is known as the range element. Minus 2 is related with 5, minus 2 is known as the range element for 5. You cannot say that 1 is the range element for 5. Minus 2 is the only range element for 5. 6 is the only range element for 1. The second component always represents the range element and the first component always represents the domain element. Mako kotha recall korisu. R is a relation from A to B means R is a subset of the Cartesian product of A cross B. A cross B contains ordered pairs. That's why R contains ordered pairs. So whenever any set contains ordered pair, it should be a relation, and there should be a relation between X and Y. It will be mentioned there. For different values of X, you will get different values of y. For different values of x, you will get different values of y. The values of x are known as domain elements and the values of y are known as range elements for this one. Generally, range elements are represented by y and the domain elements are represented by x. Is it clear? So, here also, so under this one condition as it is given there, for different values of x, suppose you have got that 1, 6, 5, minus 2. So many different ordered pairs are there, which will satisfy the condition. For different values of x, you will get different values of y. But remember, to be an element of this one relation R, a R or a element hobo babe, this condition should be also satisfied. A condition to satisfy. What is the condition? X and y should be whole numbers. That's why we have got that 1 and 6 are whole numbers and it will satisfy the condition here. So that's why it is an element of R. But is it an element of R? No. Though it is satisfy the condition, but both of them are not whole numbers. Minus 2 is not a whole number. That's why it is not belongs to R and it only belongs to R. So such type of ordered pairs you have to find it out. So let's try to find it out. What type of ordered pairs you will get? Okay, so let us try to find it out. Y is equal to 8 minus 6. Correct. So what is the smallest whole number? 4x is equal to 0. Let us try to find it out. You cannot consider minus 1 because whole number starts from 0. 4x is equal to 0, y is equal to 8. The corresponding ordered pair will be 0, 8. Am I correct? For x is equal to 1, y is equal to what? 40 to 1, so it will be 6. So the order is 1, 6. For x is equal to 2, y is equal to 4. X is equal to 2 means 2 to the 4. 8 minus 4 is equal to 4. So 2, 4. For x is equal to 3, y is equal to 3 to the 6, y is equal to 2. So this one implies 3, 2. For x is equal to 4, y is equal to 0. 4 to the 8, 8 minus 8, 0. X is equal to 4, y is equal to 0. For x is equal to 5, y is equal to 5 to the 10, so it will be minus 2. But what is the main condition? Both x and y should be whole numbers, but we are getting that y is equal to minus 2, this is not a whole number, so that's why we will not proceed once. Because to satisfy this condition, and both the components x and y should be whole numbers. এটা সব কি করব আমি x আর y ভ্যালুগুলোকে for different values of x you are getting different values of y and their corresponding ordered pair is this one. All those ordered pairs will satisfy these conditions as well as all the components are whole number. So that's why R is a relation. What is the domain here? Already I have told it. Someone may ask, sir, why you are not considering x is equal to minus 1? Because x should be whole number. That's why I am not considering x is equal to minus 1. So listen, domain means what? The first components will form the domain. Domain itself is a set. Always remember. Domain, codomain. Have you got it? This one is A and this one is B. This one is... Okay? All the first components are known as domain. Here, relation between two sets, A and B. So that's why domain, codomain, range, all are known as sets. Remember. So that's why you have to write down the answer in set form. The values of x are known as domain elements. So 0, 1, 2, 3, 4. So what is the range? Range means what? Range means the second components. So you can say that 2, 0, 2, 4, 6, 8. I have written a systematic way. You can write down 8, 6, 4, 2, 0. Order does not matter. So this is the range. But remember that the relation, this relation is defined between two whole numbers. Am I correct? This one is whole number, this one is whole number. How you have to come to know? Because values of x are whole numbers, and y is whole numbers. X belongs to the elements of the first set and y belongs to the elements of the second set. X and y are whole numbers. So that is from here 0, 1, 2, 3 like that, and 0, 1, 2, 3, all those numbers are here. The related elements, 0 is related with what? 0 is related with 8, 1 is related with 6, am I correct? 2 is related with 4, 3 is related with 2. All those whole numbers are there. Out of all those infinite whole numbers, these whole numbers are related. Got it? In this set, how many whole numbers are there? 1, 2, 3, 4, 5, 6. So many whole numbers are there. But under this condition, 0 is related with 8, 1 is related with 6, 2 is related with 4, 3 is related with 2, like that only. Remember, the relation is defined from whole number set to whole number set. But from the first set, the elements which are related are known as domain elements. A condition to under first set or zigilak element related with a hibilak domain element. If R is a relation, remember, a relation has a data set of the defined project. Under this relation means condition which should be satisfied by X and Y. So a condition to under first set or zigilak element related with only 0, 1, 2, 3, 4, all these 4 elements are related. So that's why these are known as domain elements. Others are not. For X is equal to 5, you are getting -2, but -2 is not there because it's a set of whole numbers. For X is equal to -5, you are getting Y is equal to -2 from here this condition. For X is equal to 5, Y is equal to -2, but Y is equal to -2 is not there. That's why 5 is not related. I have left it here, just like this one. Now 5 here because 5 is equal element related হৈ আছে 5 or কাৰণে যদি corresponding y পাইছা that y is not there, so 5 is not related আৰু a to set related যিবিলাক element নহয় they are not known as domain elements. That's why the domain elements are 5, 0, 1, 2, 3, 4, 5. These 5 domain elements are there, but 5 is not the domain element because 5 is not related. For X is equal to 6, Y is equal to what? Put it here, 6 to the 12, it will be -4. Again, for X is equal to 6, it is whole number, no doubt. For X is equal to 6, what is the value of Y? -4. -4 is not there because elements of the second set are always represented by Y. -4 is not there, that's why 6 is not related. And in the same way, the related elements of the second set are known as range elements. First set or related element bilakok domain element koba, and second set or related element bilakok range element koba. What are the range elements? 0, 2, 4, 6, and 8. And the whole second set is known as codomain. Whole second set is known as codomain. Codomain is the whole number set. What is range set? Range set 0, 1, 2, 0, 2, 4, 6, and 8 is the range set. Range set to what I codomain or bit or one. So I think you have got it earlier. Remember that range lies inside the codomain set. Okay, so we have got a domain as well as range, and now we are going to represent R as a set of ordered pairs. So therefore R is equal to set of ordered pair means first ordered pair is 0, 8, 1, 6, 2, 4, 3, 2, next one is 4, 0. Is it clear? So this is the relation R which contains exactly how many ordered pairs? 5 ordered pairs. Generally it is defined between whole numbers or whole numbers. If I have whole numbers of do there, it is some whole number related to 5 or element price. This is not a whole number, so that's why I mean 5 kilo domain element hobo noire, 6 kilo domain element hobo noire. Okay, so in this way we will try to find out the domain as well as range. Domains means the first components of the relation or ordered pairs, and second components always represent the range set. Range itself is a set. What is the codomain set here? Because the relation is defined to what? X from whole number and Y is an element also a whole number. As it is lies between whole number to whole number. So that's why codomain set is a whole number set. I hope you are getting my point. If you are not getting, just pause the video and think once again. Obviously you will get my point. Listen in a steady manner and be concentrated. Thank you so much.